Hello everyone, welcome to the channel SRS. This is Sumit Roy and we'll study digital electronics today in that multiplexer. So what happens in a multiplexer? A multiplexer is also abbreviated as MUX, so I'll refer it as MUX from now on. As you can see that I've written it as many to one. Many in this case is essentially inputs and one is essentially output. So what we are having is, as a MUX is, there are many possible inputs and one output. Now, how an input can be chosen? By the help of selection lines. So there has to be numerous selection lines. So this is input, this is selection, and this is output. Now the problem here is how we can select, means maybe first, second, third, fourth or whatever. So how we can select? So we, by the help of binary number system, we name these inputs. What happens is, for an instance, I'll take 2:1 MUX. For 2:1 MUX, if I'll draw the diagram, what is the part in 2:1 MUX is, there are two possible inputs and one is output. Let us name it as I0 and I1 and let the output be Y. So these are inputs and these are outputs. Okay, so now I0 can be chosen or I1 can be chosen based on the selection line. Now, if I name it as if these are only two inputs, so in the selection only one selection line is required. As for selection, let us name it as 0 and let us name it as 1. If selection line is 0, then this will be at the output, that is S and Y. So if 0 is at the selection, then output will be I0, and if 1 is at the selection, then I1 will be at the I0. Y. So this is the basis of close to one multiplexer. That is, input will flow to the output, particular input will flow to the output based on the selection line. If I choose 4:1 MUX, then for an instance 4:1 MUX can be written as this. There are possible 4 inputs and 2 selections are required and 1 is the output. Why? Because I'll tell you, let this be I0, this be I1, this be I2, this be I3, and there are 2 selection lines, S1 and S0. This is MSB, this is LSB, and Y is the output. Now I'll tell you why we require 2 possible selection lines. As there are 4 inputs, let these be 2⁻n. That is, 2⁻n possible number of inputs are there. Therefore, that is, in this case it is 4. In this case it is 4. So n is obviously 2. So 2 are the selections. N equal to 2. For 2 to the power n possible inputs, n number of selections are required. This, for an instance, this, if I write as S1 as 0, so for 0, I0 will be chosen, for 0, 1, I1 will be chosen, for 1, 0, I2 will be chosen, and for 1, 1, I3 will be chosen. So this is the basis of selection. Based on what is the value of S0, S1 and S0, we get the value of Y. So based on this we are working. Now, in multiplexer, same will go for 8:1 multiplexer, same will go for 16:1 multiplexer, and so on. For multiplexer, I will say what a multiplexer means, because at least some sort of ground has been made. So what is a multiplexer is? Multiplexer is many to one, and not only on which ground, that is, it can be TDM, time division multiplexing. That is what we are doing here. That is, if we put 0, then one thing will flow, and if we put 1, then the another thing will flow for 2:1 multiplexer. So actually it's a switching device. For 0, this will be switched and this key will be kept as open, and for 1, this will be kept as open and this will be closed. For same, these are all actually multiplexer can be regarded as only a switching device. So this is a switching device. Particularly at any instant, based on the value of the selection, one key will remain closed and others will be open. For example, if I pick this, so for 1, 1, this key will remain closed and others will be open. For 1 0, this will remain closed and others will be open. So this is known as time division multiplexing. There is also possibility of space division multiplexing, that is a particular space has been divided. For instance, let us take a big space has been divided into two parts. For 0 we'll pick space 1 and for 1 we'll pick space 2. If that space is divided into 4 parts, for 0 0 we'll pick space 1, for 0 1 we'll pick space 2 and 3 and 4 and so on. This is known as space division multiplexing. It is used in number of applications, so we'll discuss them later. There is another multiplexer, that is multiplexing possibility, that is by the help of frequency, that is known as frequency division multiplexing. That has the application in this wireless FM, that is 88 megahertz to 108 megahertz. The frequency channel has been divided into numerous commercial channels, that is for 98 something, 91, 92, whatever be the frequency, central frequency. Based on that, other channels, numerous channels are divided. So that is known as frequency division multiplexing. So there are also CDM possibilities, so we'll discuss them later. We'll stick to time division multiplexing for this. So I'll get into more details into the digital part, that is digital electronics part of this time division multiplexing or MUX. So 2:1 multiplexer. Now what is a 2:1 multiplexer, as I have given you and just an overview. So what is a 2:1 multiplexer is this one, that is there are possible two inputs, one is the selection and one is the output. So let us name it as I0, I1, let us be it as S, and this let be Y output. So there are possible two inputs, one selection and one output. So based on this, that is if S is 0, then output will be I0, if S is 1, output will be I1. So based on this behavior, I can write the output based on this logic. Y can be written as Si0 plus Si1 with a bar at S. That is 0 for 0, only I0 will stay, Y will be equal to I0, 0 bar is 1, that is 1 dot I0 plus 0, that is I0. And for 1, this will vanish and this will stay, that is I1. So this is the Boolean expression that can be derived from the logic. Okay. For 4:1, I'll derive it for 4:1 also. That is, there are possible 4 inputs, 2 selection lines and 1 is the output. So name it as I0, I1, I2 and I3 and name it as S1 and S0. So if I put 0, 0, then Y will have I0. If I put 0, 1, it will have I1. If I put 1, 0, I2 and 1, 1 will give us I3. So based on this logic, I'll write it here. S1 is 0, 0, 0, 0, 1, 1, 0, 1, 1 and Y will be I0, I1, I2 and I3. Based on this logic, what we can derive is Y equal to S1 S0, because ultimately selection line will play the part for the selection. S1 S0 I1 plus S1 S0 I2 plus S1 S0 I3. So for 0 0, I0 is picked. For 0 1, I1 is picked. For 1 0, I2 is picked. For 1 1, I3 is picked. So this is the Boolean expression that can be derived for 4:1 multiplexer. Same is the case with 8:1 multiplexer and followed by 16:1 multiplexer. If 8:1 multiplexer output has to be written, then I can write it as there are possible 8 inputs, and 8 inputs means 2 to the power n equal to 8, n equal to 3. So there are 3 selection lines and 1 is output. So S2, S1, S0. So if we have to write it, because it will be just the same logic, but if we have to write it, then Y can be written as S2, S1, S0, I0 plus S2, S1, S0, I1 and followed by all the parts. So I'll write it. So based on this, that is for 0, 0, 0, I0 will be picked, 0, 0, 0, I0 will be picked, for 0, 0, 1, I1 will be picked, for 0, 1, 0, I2 will be picked, for 0, 1, 1, I3 will be picked. For 1, 0, 0, this, for 1, 0, 1, for 1, 1 and 0, and for 1, 1 and 1, this will be picked. So, yes, this is it. For 0, 0, 0, I0 and ultimately 1, 1, 1 will give us I7. So same is the case for 16 cross 1 multiplexer, and that will have 16 inputs, 4 selection lines and 1 is the output. But there is certain thing about 16 cross 1 multiplexer, that is 16 cross 1 multiplexer can be derived can be constructed by the help of 4 cross 1 multiplexer. So we'll see it in the next lecture. That is a very interesting circuit followed by demultiplexer, encoder and decoder. So till then, goodbye. Consider subscribing and like, comment, share. Press the bell icon. You will get all the notifications.